Yeah, Assalamualaikum warahmatullahi wabarakatuh and good morning class.
Good morning, Miss.
Waalaikumsalam.
Okay,
Waalaikumsalam, Miss.
right. Okay,
Aku
for the
salam,
first
Miss.
question in our tutorial, this is the second tutorial. The second and third tutorial will cover for 5.2 alkenes. Okay, so we'll start with these non-face-to-face questions with 9 hour 2. So the questions ask you to compare the boiling point. So the keyword here is boiling point between cis-2-pentene and trans-2-pentene. So you need to compare between these molecules. So what should you do first? Can you simply explain them, or you need to first take out the structural formula of cis-2 and trans-2-pentene?
Take out the structural formula first.
Okay, now let's first draw the 2-pentene. Okay, just the 2-pentene. Could you please tell me how many carbons that make up the parent chain?
5.
From the name, yes, 5 carbons. So we have 1, 2, 3, 4, and 5. And then at carbon number 2, this carbon number 2 belongs to the functional group of carbon-carbon double bond. So means your carbon double bond will be somewhere around here. Okay, means each of these carbon-carbon double bond, they are sp2 hybridized, means dia akan ada 2 bond. Okay, kalau dia tak tunjuk kat sini means they belongs to hydrogen. So awak ada 1 alkyl group and 1 hydrogen, 1 alkyl group and 1 hydrogen. Now, we need to draw the cis and trans isomers. As for the cis-2-pentene, okay, kita fokus pada the carbon-carbon double bond here and then show the bonding between the hydrogen and also the hydrogen on the side, or you can also draw the alkyl group on the same side because the cis belongs to same side. Okay, so we have here CH3, and here we have CH2, CH3. So this is what we call isomers, cis or trans.
Cis.
The cis, okay, cis because we have the same group on the same side. Okay, what about the trans? The trans kita akan ada, yes, same group but on different sides. So we focus on the carbon-carbon double bond. And then instead of having both hydrogen on the same side, kita akan letak satu atas, satu bawah. The rest kita remain unchanged. So CH2, CH3. Okay, so we could see the same group but on different side. Okay, now how are we going to determine whether cis or trans got higher boiling point? Okay, how are we going to do this? Bila kita sebut boiling point, we're going to look at apa?
The polarity.
Check the polarity.
Nah. Okay, the polarity good, but then kita nak tengok the intermolecular forces, is it? What kind of intermolecular forces present? Okay. In other words, kena tahu polarity of a molecule lah. Okay, kita list out balik. We learned about hydrogen bond, we learned about dipole-dipole, and we learned about London forces. Each of them got different criteria to be met. Okay, untuk these 2-pentene, okay, 2-pentene, tak kisahlah cis or trans, do you think they are capable to form hydrogen bond between them? Are they capable to form hydrogen bond between cis and cis-2-pentene and even between trans-2-pentenes?
No.
No, okay, so hydrogen bond dah disqualified sebab dia tak obey the criteria. They got no handphone on them, and also the neighboring carbon, which is the same molecule in here, got no lone pair on them. So hydrogen bond tak boleh. We are left with only dipole-dipole and London forces. We know dipole-dipole only happen between what kind of molecule? Polar or non-polar? Dipole-dipole interactions formed between polar or non-polar molecules?
Polar.
Polar molecule. Good. Kalau London forces, dia berlaku pada
Non-polar.
non-polar. Okay, good. So now you need to identify which of these two belongs to polar and non-polar molecule. So how are we going to do this? When we say polarity, so polarity kita akan tentukan when you have different or same electronegativity. Okay, at the moment we have this group of carbon and also alkyl group carbon juga. Okay, but then between these two carbon, So these two carbons belongs to CC dan juga alkyl group. Who do you think got greater amount of electrons on them? The C double bond C or C single bond C? Who do you think got more electrons on them?
Double bond.
E double
The double
bond.
bond. Okay, so kita akan denote this carbon-carbon double bond as the partially negative. Okay, partially negative. It means this alkyl group got only C and H on them will be the partially positive, partially positive. When determining polarity of a molecule, we need to first identify the polar bond, the polarity of a bond. So now we have both C and C, but one with partially positive, but another one with more negative charge on them. Tak adalah charge dia partially. So kalau kita nak tentukan polarity of a bond, kita akan lukis apa dekat atas tu?
Arrow.
Arrow.
Okay, the polar arrow pointing towards a more electronegative or a more electropositive atom.
More
Negative.
electronegative.
Yes, more electronegative is pointing towards this carbon-carbon double bond, means this CH to CH3 also pointing towards CH to CH3. Maksudnya dia akan tertumpu electrons dekat carbon-carbon double bond. Dah cause imbalance in terms of amount of electron density. Okay, jadi kita boleh kata yang this cis2 pentene cannot, their bond dipoles cannot cancel out each other. So the bond dipoles cannot cancel out each other means their mu is not equal to 0. Therefore, they are polar or non-polar. Kalau tak boleh cancel out,
Polar.
okay, polar molecule.
Polar.
So these polar molecules got what kind of intermolecular forces present in them?
Dipole.
The dipole, ada tak London forces juga? Kalau ada dipole?
Ada.
Ada, okay. Now kita look at the trans-2 pentene. Same goes to this trans-2 pentene. We have this partially negative on the carbon-carbon double bond, partially positive and partially positive. So we're going to draw the polar arrow. The polar arrow pointing towards the carbon-carbon double bond. And then this carbon-carbon double bond pointing towards it. So kita akan nampak one arrow comes from upper side and the other one comes from lower side here. So dia akan cancel out each other, right? Bila atas bawah dia cancel out each other. Okay, so what kind of conclusions can be made here? In terms of their mu, the resultant dipole moment, will they equal to 0 or not equal to 0?
Equals.
Yeah, equal because the bond dipoles can cancel out each other. Means they belongs to non-polar or polar molecules.
Non.
Non-polar.
Bila ada non-polar molecules interact with non-polar molecules, what kind
Equal
of
to zero.
intermolecular forces present?
London forces.
London forces on the good. Wow, when you are dealing with these intermolecular forces, kita akan tengok sekarang
forces.
ni diorang punya, yes, diorang punya size ada beza ke sama je?
Sama.
Sama. When they got comparable size, jadi kita akan have dipole got greater strength, okay, untuk kita break the forces between them. Jadi what will happen to boiling point of cis? Who's got higher bonding points, cis or trans?
Cis.
Cis to pentene got higher bonding point, just slightly higher sebab diorang punya size sama, diorang punya surface area pun lebih kurang, cuma dia the polarity sahaja. So ini adalah lower bonding point. So okay, kalau dia minta explain, awak ayat lah in terms of cis to pentene apa yang awak jumpa, trans to pentene apa yang awak jumpa. Kena bagi tahu type of molecules yang kita ada. Okay, proceed to the next question. Okay, this involves the reactions in alkene. So we know we learned 3 types of reactions taking place in alkene. One is eliminations, got 2 reactions. And then we have electrophilic additions, we have 6 reactions. And then the last one we have oxidative cleavage, we got 2 reactions. Okay, jadi altogether 10 untuk alkene. Right, now the questions ask you to write the equations. Bila sebut equations, you must have the reactant, you have the conditions together with reagent, and then the product to be formed. Okay, it's already stated here the preparations of propene. Preparations of propene maksudnya preparations of alkene. Can I know how many reactions under preparations of propene? Berapa yang kena tahu kalau nak prepare alkene?
2.
Dua. Okay,
Dua.
the dua adalah dehydrohalogenations and dehydrations. Which one of these two question number 1 and 2 Roman belongs to dehydrations? Number 1 or number 2 kalau dehydration?
Number 2.
2.
Number 2. So can I know reagent to be used in dehydrations reaction? Kita guna reagent apa? From dehydrations, we know we want to remove D itu maksudnya eliminate, we want to remove apa?
Water.
Hydrations.
OH.
You want to remove water, means you want to remove negative H and you want to remove H and also OH, right? Okay, bila kita nak remove H dengan OH, we can see we have OH in here characterized by base. Contoh, kita nampak dia macam a base lah because they got lone pair. Means kalau kita nak guna reagent, kena yang counteract the base. Means kita akan guna acid catalyst. So can you please tell me the reagents untuk dehydrations reaction?
Concentrated H2SO4.
Concentrated H2SO4.
Concentrated H2SO4 and heat, right? Okay, so this is the reagent. Awak kena hafal benda ni. Reactions without reagents tak ada markah. Sorry. Okay, means the other one belongs to the dehydrohalogenations. Dehydrohalogenations, we want to remove apa? Kita nak remove hydro means kita nak remove hydrogen kan?
Yes, miss. And halogen.
Kita nak remove halogen. Okay, now on your we know the halogen belongs to group 17, negative charge. So kalau dia pair up with H, dia akan dapat contoh HCl, HBr. Okay, dia tu belongs to acid. So kalau acid, kita nak counteract dengan reagents macam mana? Adakah kita nak guna acid juga?
Tidak.
No.
So kita akan guna base. So base yang kita akan guna adalah
KOH.
KOH in ethanol. Dia buat slash ni dia nak cakap in ethanol. Awak tak tulis slash, awak tulis in ethanol pun kita terima. In ethanol under reflux. Okay, you need to write this complete sentence like this, okay? So kita akan start with first the structural formula. How are you going to draw the structural formula of 2-chloropropane? How are you going to start drawing this? Tell me, how are you going to start doing the structural formula? We learned already the
List down the
nomenclature starts from the parent chain, right? We have this propane. How many carbons?
3.
3. So do we have
Three.
any carbon double bond in this propane?
No.
No. Okay. So settle. Dia akan jadi alkene saja with
No.
carbons. And then the number 2 here belongs to the chloro. Can I know this chloro belongs to substituents or the family?
substituent.
Substituents.
Substituents at carbon number 2. So kita put Cl, means the rest belongs to hydrogen, CH3, CH, CH3. So this is your 2-chloropropane. Okay, and then we undergo reactions by using this KOH in ethanol and reflux. Okay, we're going to remove hydrogens and halogen. Okay, to make it more clearer, kita akan show the bonding between them. Okay, let's see, saya pada Allahu Akbar. Saya padam this H. H pun saya nak tunjuk the bonding supaya awak nampak. So here we have another H. Sorry. Still got H on them. Okay, now we want to remove this Cl and H. By removing this, we are going to get apa yang kita nak dapat dari sini. Bila eliminations, you want to form from single ke multiple. Jadi kita dapat class of compound apa yang kita akan hasilkan kat sini? Class of compound apa?
Propene.
Propene. In between carbon number 1 and 2. Boleh tak kita gerakkan double bond kat sini untuk buat sebelah kiri pula? Boleh tak kita gerakkan? Tak boleh dah sebab dia sama saja dia punya environment. Okay, so kita aim untuk dapatkan double bond. Okay, now the second preparations of propene kita boleh buat daripada alcohol. So bila alcohol kita akan remove water. So alcohol again, 1, 2, 3, have propanol. But now your OH is located at carbon number 1. Okay, hati-hati. Means it's going to be CH2. Ini akan jadi CH. Here we have H in here. Belongs to CH3. Okay, now we want to remove this hydrogen and water. Okay, with the presence of concentrated H2SO4 and heat, yes, and then you're gonna get exactly the same answer as the one yang kita form dekat atas tadi, which is the propene. Propene tak ada positional isomer sebab bila digerakkan ke kiri pun masih propene juga. So tak perlu letak one propene. Starting from carbon number 4 baru kita letak numbering untuk the positions of your carbon-carbon double bond. Kita recall sekali lah the alkene dan nomenclature. Okay, next one. The questions wants you to define. Yes?
Nak tanya, for the reaction, right? After once we write the species form, macam yang ni kita dapat propene. Yang balance macam KCl dengan H2
boleh. Sebab dia kena letak lah. Tapi kalau untuk macam contoh dia kalau dia minta equations kena tulis full. Kalau dia just suruh determine the product, okay, untuk product kita akan fokus pada the organic compound yang kita dapatkan double bond tu. Tapi still kena tulis lah. Thank you for reminding me. Kena bagi tahu lah you remove apa. Kalau dia minta equations ke mana lengkap. Tapi usually lah side product ni dia tak fokus sangat, dia fokus pada your organic compound.
Okay, Miss.
Okay. Unless chemical test memang betul kena ada side product. Kalau yang lain tu selalunya dia tak tengok sangat lah yang side product tu. Okay, next question. Question number 3. They ask you to define Shazam's rule. So this Shazam's rule involves in elimination reactions. In other words, dia takes maksudnya kita kena apply this Shazam rules in preparations of alkene only. Okay, whenever you have preparations of alkene, kita kena check whether to form major or minor product by using this Shazam rule. It states the alkene with most highly substituted alkene gonna be the major product. Okay, macam mana kita tentukan? Okay, so let's say you have this carbon-carbon double bond and then attached to it we have 1, 2, 3, 4 alkyl group. So means we have 4 substituents around this carbon-carbon double bond, is it? So having alkyl group surrounding this carbon-carbon double bond means the alkene will be the most stable. Jadi kita akan denote dia sebagai major product. So kena tulis major product, minor product. Okay, sebab major product maksudnya dia akan hasilkan banyak. Minor akan dapat juga tapi maybe percentage dia sedikit. Itu maksud Shazam's rule. Okay, so now look at the second questions. Draw the structural formulae of alkenes that would be formed when 2-bromo-2-methyl-butane. So dia bagi dekat sini 2-bromo-2-methyl-butane to start with. React with potassium hydroxide in ethanol. Dia dah bagi tahu awak the starting materials together with the reagents to be used. Dia minta awak keluarkan dan kena draw alkenes. Dia dah bagi dekat sini alkenes means more than one alkene to be formed. Okay, jadi kita akan expect kita ada lebih pada satu alkene yang akan kita hasilkan, and from the alkenes formed you need to determine who's going to be the major and who's going to be the minor product. Even though the questions only ask for major product, kalau dia major maksudnya lagi satu adalah minor. Okay, so kita akan start with this 2-bromo-2-methyl-butane. How are we going to draw this molecule? How are we going to start to draw this molecule? Kita start dengan apa dulu?
Parent.
The parent chain, how many carbon?
4.
4 carbon. 1, 2, 3, and 4. So this number 2 methyl and 2 bromo means that carbon number 2 we have 2 branches in them. So one of them occupied by this CH3, another one occupied by this Br. Okay, bromo. Okay, the rest kita akan fill in. Kita ada CH3, kita ada CH2, kita ada CH3. So this is your 2-bromo 2-methyl butane. And then you want to react them with this potassium hydroxide in ethanol, dia dah bagi. Potassium hydroxide in ethanol and heat. Okay, walaupun heat lah, sorry, reflux. Dia tak bagi tahu reflux, tapi awak kena tahu dia perlukan reflux. Tak ada reflux, hanya potassium hydroxide in ethanol, dikira salah. Okay, now from these reactions, we know this reagent belongs to element. Yes, Hannah?
Why cannot letak heat?
Heat dengan reflux benda yang sama, tapi reflux dia require water. Heat only. Kalau reflux dia ada heat dan juga dia ada kitaran air.
Oh, okay.
Okay, so we have this KOH ethanol and reflux, and then kita nak dapatkan alkene, so we aim to involve 2 carbons. One of the carbon kita akan guna this carbon bearing the Br, is it? We want to remove the Br, right?
Yes, Miss.
Okay, means sebab kalau kita nak buat alkene, you need to involve 2 carbons. You need to look at the adjacent carbon. The adjacent means the next carbon located to this carbon bearing the Br. So we have how many possibilities to form alkene? Kita tengok carbon adjacent to this carbon bearing the Br. Ada berapa carbon keliling dia?
3.
1, 2, 3.
Yes, Miss.
Kalau tengok adjacent carbon, we have 3 carbons. But then you have to look at their environment as well. Adakah semua akan dapat produk yang berlainan? Okay, kenapa kita aim for the adjacent carbon? We want to form alkene. In order to form alkene, we need to remove something. That something must comes from 2 different carbon. If you already took this Br from this second carbon, means the hydrogens cannot be taken from the same carbon sebab kita akan form more, macam ni, electron deficit even more. Electron deficit species. Jadi kita akan ambil the adjacent carbon sebab dapatkan carbon double bond. Okay, that's why kita ada this here 3 possibilities. Because we have hydrogen from the first carbon, third carbon and also the carbon up here. Okay, now, adakah kita akan dapat 3 products of alkene just because we have 3 carbon adjacent to this carbon bearing the Br? Okay, look for the, here I put A and B carbon. Look at the A carbon. The A carbon, if we start the numbering from A, means kita akan ada 1, 2, 3 and 4, is it?
Yes.
Okay, and then the carbon bearing the Br is located at carbon number 2. Okay, kalau kita start our numbering from carbon B, we have 1, 2, 3 and 4, is it?
Yes.
Are we going to get the same product or different product if we start if we take the A and B? Kita nak tengok dapat sama produk ke tak kalau numbering tu start pada A dengan B? Tadi awak tengok numbering dia sama kan? Walaupun dia atas dengan tepi kan?
Sama, Miss.
Yeah.
Dia numbering sama, maksudnya environment dia orang sama. Maksudnya kalau awak buat A asing-asing, produk yang dapat hanyalah sama, produk yang sama. Kita buat double bond dekat atas pun numbering start dari situ, kita buat double bond dari kiri pun numbering start dari situ. Tu maksudnya. Okay.
Okay.
Maksudnya walaupun you ada 3 carbon adjacent to this carbon bearing the Br, but then the possible carbon-carbon double bond yang kita akan dapat hanyalah 2. Okay. Jadi tinggallah carbon on the left and carbon on the right, and carbon number 1 and carbon number 3. Okay, kita akan buat in between 1 and 2 ataupun 2 and 3 lah our product, boleh? Faham ke itu?
Faham, Miss.
Faham.
Okay, so kita lukis balik lah. Kalau kita nak buat between carbon number 1 and carbon number 2, kita akan form double bond here. Means one of the hydrogen in here will be taken to pair up with the Br to be eliminated. So kita akan dapat carbon-carbon double bond dekat situ. So left with only CH2. Here we have CH3, jangan lupa. And we have CH2 and CH3. This is the first product to be formed. Another product, we're going to form carbon-carbon double bond in between carbon number 2 and 3 by taking one of the hydrogen from carbon number 3. So kita akan dapat 1, 2, 3, 4 macam tu. Okay, and then we have this CH3. Okay, so kita ambil apa-apa. Bawah ni kita ada CH3. At carbon number 3 here we have CH, and then the last one we have CH3. Okay, so sekarang ni look at your carbon-carbon double bond, highlight them. Okay, kita nak tengok sekarang how are we going to determine whether who's going to be the major and minor product. Okay, major and minor product can be determined by applying Shazam's rule. Okay, look at this carbon-carbon double bond. How many substituents surrounds this carbon-carbon double bond? Okay, boleh beritahu saya tak berapa banyak yang untuk yang atas, ada berapa banyak alkyl group attached to it?
2.
2, 1, 2. Okay, what about the one yang kat bawah? Ada berapa alkyl group attached to it?
3.
So, 2 dengan 3. Siapa yang akan jadi major product?
3.
Yang 3 punya. So, kita kena label dia major product. What about the other one? Kita kena tulis dia sebagai minor
Minor product.
product. Okay, good. Okay, boleh
Boleh, Miss.
Okay, kena tahu tentukan produk sebab kalau soalan minta mechanism, you must always go for this major product, the formations of major product. Okay, next one. Kita proceed. Still on preparations of alkene. Okay, it states here, acid catalyst dehydration. So it already states dehydrations. You want to remove water. Okay, of siapa? Of 3-methyl 2-pentanol. Okay, gives a mixture of alkenes. Okay, mixture of alkene means more than one product to be formed. Now the questions wants you to write the chemical equations and then draw the structures of all the product formed. Okay, you must always start with the general reactions and then barulah kita tentukan produk apa yang dapat. Start dengan kita punya starting material, we have 3-methyl 2-pentanol. Means the longest carbon chain will be
5 carbon.
5 carbon.
5, 1, 2, 3, 4, and 1. The number 2 there belongs to family or alkyl or substituents.
Family.
The number, the family lah, 2 all, okay? So at carbon number 2, let's say we start numbering from the left, we have OH attached to this carbon number 2. Okay, what about carbon number 3? They belongs to family or substituents? It's the family or the prefix?
Substituent.
Yeah, the
Substituent.
substituents at carbon number 3. So we have CH3. And then fill in your structure with hydrogen, CH3, CH, CH, CH2, CH3. Okay, this is your 3-methyl 2-pentanol. Okay, and then you are going to undergo these dehydration reactions by using disebut acid catalyst. Kita akan guna
Concentrated H2. H2SO4.
heat. Okay. So sekarang ni kita akan predict the product formed. Okay, kita kena keluarkan dulu. Kita nak remove apa? Nak remove water kan? So means the carbon bearing the OH, kita akan remove the OH, is it?
Yes.
Yes, Miss.
Sama juga macam tadi, kita kena tengok the adjacent carbon. How many adjacent carbon do we have?
2.
2.
2. So we have one in here, another one in here. Means there are possibilities for you to form carbon-carbon double bond between these two carbons. Jadi kita lukis siap-siap lah. Okay, kalau kita remove the first carbon hydrogen, so kita lukis 1, 2, 3, 4, 5, and then we form the double bond between first and second carbon. Okay, kalau yang satu lagi, kita form 1, 2, 3, 4, 5 buat antara carbon number 2 and 3. Jangan tinggal macam ni, structure ni tak betul. Lengkapkan CH2, here we have CH, here we have this CH3, dan kita ada CH2, CH, okay, here we have CH as well, CH2 and CH3. Okay, yang ni pula kita ada CH3, di sini kita ada CH, here we have CH3, CH2, CH3. So the molecular formula is the same, tetapi kita punya alkene berbeza sebab apa? Okay. Ni baru 2 so kita nampak. Okay, now let's see. There are cases, okay, when you remove kan kita undergo mechanism, okay, by right kita akan remove this OH, means kita akan dapat carbocation ion kan?
Yes, miss.
Bila dapat carbocation ion, always look for the possibilities if they can rearrange or not to get a more stable carbocation. Okay, at the moment you have secondary, and now kalau kita katalah kita nak dapatkan kat sini, maybe kita boleh dapat tertiary, is it? Masih lagi stable lah, kan? Kalau kita buat rearrangement. Ni jadi kita
Yes,
akan
ma'am.
cover lah, cuma saya nak recall. Okay, sometimes even though you have formed a more stable carbocation, but then the product kadang-kadang takkan jadi yang lain pun, dia akan jadi benda yang sama. Faham tak? At the moment you have these two product. Okay, you form carbon-carbon double bond between the first and second, and then second and third, is it?
Betul, miss.
Okay, if you happen to rearrange your carbocation to the third carbon here, okay, you have your apa kita panggil ni, adjacent carbon of carbon number 2 and here kan? Betul tak? Awak boleh buat double bond dekat sini ataupun sini, right?
Yes, miss.
Okay, so jangan pelik, walaupun awak rearrange, awak masih dapat produk yang sama. Sebab kalau awak tengok, awak dah ada belum produk yang between carbon number 2 and 3?
Yes.
Dah.
Dah ada kan? So awak jangan tengok kalau dah rearrange kena ada produk pula. Dia sometimes ada, sometimes tak. Kenapa tak berlaku dalam kes ni? Sebab apa? Sebab your carbon chain, walaupun kita dah rearrange contoh, you ada carbocation dekat tengah ni, the environment is the same on both side, left and right. Sini pun 2 carbon, sini pun 2 carbon. Sebab tu dia punya produk akan dapat sama. Unless you got greater length in terms of carbon chain, mungkin boleh dapat yang lagi produk yang lagi satu. Itu clear?
Yes.
Okay, then.
Yes, miss.
Okay. So 2 produk ni je lah sebenarnya. Okay, now tell me who's going to be the major and minor product? The first or second one going to be the major product?
Second.
Ya,
Second
second one. Maka dia label dia major product. The other one akan jadi minor product. Okay. Tu boleh kali dia punya byproduct dia tadi apa? Kita remove water kan? Plus H2O.
Yes, miss.
Okay, good. Okay, next one. The questions wants you to outline the mechanism. Outline the mechanism means you use the curly arrow. Curly arrow to show the movement of electrons. Okay, but each and every time you want to form this mechanism, please first write the general reactions. But for this question, they already ask you for general equations in question A. Jadi tak perlu dah lah buat untuk question seterusnya kan. Ini dah ada, tak perlu. Tapi kalau soalan terus minta mechanism, tak minta chemical equation dulu, tolong keluarkan chemical equation dahulu. Okay?
Okay, miss.
Okay, miss.
Okay, right. So dia ada separate marks untuk general equations. Okay, now you need to outline the mechanism for the formations of major product. Even if the question didn't mention major product, kalau you have more than one product to be formed, always go for major product when dealing with mechanism. Okay, so kita akan buat mechanism ni. Mechanism untuk dehydrations of alcohol involve how many steps?
2.
You sure tu?
3.
3. Okay, so kita lukis balik structure kita ada 1, 2, 3, 4 and 5 sebab kita nak start pada dia ni. Carbon number 2 we have OH. Carbon number 3 we have CH3. The rest is hydrogen. Okay, H, CH2, CH3. Okay, what is the first step? Apa aim kita? Kita nak dapatkan apa dalam first step? We are going to form.
Protonated alcohol.
Okay, protonated alcohol maksudnya alcohol with proton. Tu aim dia. Sekarang ni dah ada belum alcohol with proton? Dalam awak punya alcohol?
Belum.
Belum ada. Jadi kita nak jadikan OH ni sekarang jadi positif. Untuk dia jadi positif, dia kena bagi satu daripada dia punya lone pair kepada siapa. Okay, kita tengok siapa kita punya reagent tadi. We have H2SO4, right? One and only.
Yes.
Okay, kita tak ada benda lain. So kita akan guna H2SO4, but please draw them. Sebab kita nak melibatkan bond breaking. So kena show siapa yang kita nak break nanti. Jadi kena buka sikit structure tu. HOSO3H. Jangan tulis H2SO4. Lepas tu pergi ambil dia, tak mau. Okay? Keluarkan dia macam ni sebab kita nak show the bond breaking. Dalam mekanisme kena show. Awak ambil, awak pecahkan. Tu maksud dia. Bila awak pecah jadi apa? Bukannya dah pecah jadi seperti biasa. Tak. Okay. So this is your H2SO4. Siapa yang akan jadi nucleophile? Alcohol or sulfuric acid?
Alkene.
Alcohol. Okay, alcohol will become the nucleophile. Yes, nucleophile, right? So this is going to be the nucleophile with its nucleophilic site on this lone pair. And then we have this as the electrophile to be attacked. Electrophile is the one to be attacked sebab disukakan lone pair tu. Jadi, sekejap saya nak lukis sebelah ni. Senang sikit. H, kita punya lone pair kat sini. So the nucleophilic site is on this lone pair. Dia akan takes one of the hydrogen on this H2SO4. And then the bond between H and O will break. Okay, bila dia jadi macam ni, kita akan buat reaction, kita akan dapatkan produk dia. But now, apa yang kita dapat? Adakah masih sama? Tak ada sedikit perbezaan.
Ada perbezaan.
Ada perbezaan dekat mana? Dekat O
Dekat
kan? Kita dah
OH.
bagi satu.
O.
Yes. So we have these H and H. Okay. Now kita tinggal satu je lone pair awak. Means dia akan jadi positif. Okay, this is your protonated alcohol lah. Okay, untuk yang tak kenal, this is your protonated alcohol. Awak tak perlu pun nak kena tulis dia ni apa-apa. Kita just bear in mind, first step kena dapat benda ni. Okay, the second step, awak boleh terus sambung Awak boleh je terus sambung. Okay, the second step, we aim to, kita nak form apa second step?
Carboxyl ion.
Carboxyl ion. Maksud carboxyl ion, siapa yang positive charge?
Carbon.
Carbon. Okay, so now you have this positive charge on this O. Kalau nak form carboxyl ion, the nearest is the carbon bearing the O. Maksudnya, we aim to make this carbon as positive charge. Okay, macam mana kita jadikan dia positive charge? Kita kena bagi semua bond dekat this bond, single bond yang connect this carbon and O kepada oksigen. Okay, jadi apa yang kita akan buat kat sini, kita akan remove. Kita nak remove siapa?
H2O.
Yes, you are going to remove H2O by giving all the electrons to this O. So nanti kita akan dapat CH3, kita ada CH3 dan kita ada CH2, CH3. Okay, now we have this carboxyl ion on this second carbon. Okay.
Okay.
Okay, now check your carboxyl ion now. Kita punya carboxyl ion surrounded by how many alkyl groups?
Okay, Miss.
Okay. Alkyl group awak sekarang, awak punya carboxyl ion sekarang ada berapa banyak alkyl group attached to it? Tengok carboxyl ion kita, ada berapa carbon directly attached to it?
2.
Ada 2, maksudnya this carboxyl ion classes is?
Secondary.
Yes, this is secondary carboxyl ion. Okay,
Okay.
whenever you have carboxyl ion, you need to look for the possibility for them to gain a more stability, a higher stability or not. Sekarang secondary, kalau ikutkan boleh pergi sampai tertiary, tapi check juga possible ke tak untuk structure ni. Do you think that this secondary carboxyl ion can become a more stable carboxyl ion if they rearranged?
Boleh.
Boleh. Macam mana kita tahu boleh ke tak? Macam mana kita tahu boleh ke tak? Kita kena tengok adjacent carbon kan?
Yes, Miss. Adjacent carbon.
Okay, you know, yes. How many types of rearrangement do you learn?
2.
Ada dua kan? Okay, it's either 1,2 hydride or 1,2 methanide, is it?
Yes.
Yes, Miss.
And rearrangement only takes place from a less to a more stable carboxyl ion. Okay, look at your adjacent carbon. If you want to rearrange this second carbon to the first carbon, are you going to get a more stable or less stable carboxyl ion? Kalau kita nak gerakkan dia ke kiri, ke sini, dia akan dapat a more stable or less stable?
Less.
Less stable.
Stable. Jadi rearrangement perlu ke kalau dari more to less?
No.
Tak perlu. Okey, jadi kita sekarang ni kita nak aim for a more stable. Tengok pula carbon on the right. Okay, if we want to rearrange to this carbon, do you think that we can get a more stable carboxyl ion?
Yes.
Yes, sebab kita akan tengok bila you rearrange, kita tak tahu you nak buat shift apa, tapi kita nampak lagi banyak substituents surrounds this carboxyl ion, is it?
Yes.
Yes, Miss.
Yes, okay. So sekarang ni, bila ada possibility untuk dapatkan a more stable carboxyl ion, then you need to do this rearrangement step. This is extra step apart from the 3 essential steps, okay?
Okay, Miss.
Okay, so now we aim to rearrange them. Okay, bila nak rearrange, you have to show the bonding. Okay, now, on our carbon adjacent to this carboxyl ion, we have 2 bonds. 2 bonds pula. We have either, saya padam. You kena show the bonding. Okay. We have either CH3 or hydrogen to be shifted, right?
Yes, Miss.
Okay, if you, I pernah cakap, if you got hydrogen on your, if you got both hydrogen and methanide on your carbon, who do you think going to be shifted? Hydrogen or the CH3?
Hydrogen.
Okay, always go for hydrogen because it is much easier for you to transfer this hydrogen sebab dia much more smaller as compared to the methanide. So kita akan buat what kind of shift in here? What is the name of the shift taking place?
1,2 hydride shift.
Yes, kita ada 1, 2. This 1, 2 indicates they are adjacent to one another. They are next to one another. Then we have this hydride belongs to H shift. Kena tulis Okay, bukan tulis saja, kena show how are you going to transfer, maksudnya to rearrange them. Okay, kita bukannya nak bagi bond pada bond, nanti dia dapat double bond. You want to relocate the hydrogen by moving this bond of CH to the carbon here. Macam tu saja. Okay, bukan daripada H pergi C, tapi bond yang memegang C, bond C single bond H, bond tu yang pergi ke C. Bila bond yang pergi ke C, kita akan dapat a new carboxyl ion, a new stability of carboxyl ion yang duduk kat tengah ada sekarang. So bila kita rearrange, awak akan dapat H ni bukan lagi kat sini, H awak dah pergi ke sana kan? So nak bagi nampak, kita gerakkan H dah pergi ke sini, right? So ada CH2 betul tak dekat carbon tu?
Betul, Miss.
And dekat carbon ni kita akan ada carboxyl ion. So you shift this hydrogen and then you're going to get a more stable carboxyl ion, tertiary carboxyl ion. Boleh? Memang kena step ni. Step ni perlu dibuat sebelum awak pergi form alkene. Tak boleh dah form alkene baru nak rearrange. No. Rearrangement boleh happen to carboxyl ion. Okay.
Okay, Miss.
Right. And then sekarang dah tak muat, saya sambung kat sebelah. Okay, kita ambil
Boleh,
kulit this carboxyl ion. Okay, kita akan buat the third step. The third steps kita nak buat apa? Third step kita nak buat apa?
Form alkene.
Okay, formations of alkene perlukan double bond kan?
Betul.
Yes.
Okay, bila nak buat double bond, awak kena ambil satu atom daripada adjacent carbon. Okay, kita aim nak buang water yang tadi kita dah remove OH. Dengan cara you remove water, so dah tak ada OH dah, you are left with only hydrogen. So look for the adjacent carbon. You have a number of possibility in here. 1, 2 and 3. Okay, don't bother dia ada banyak mana ke tak. Awak tengok je balik general awak yang tadi. Kita ada in between 2 and 3. Okay, jadi 2 and 3 kita fokus je lah 2 and 3 terus. Kalau awak buat kat sini sekalipun, yang carbon on the right, dia punya configurations pun akan jadi 2 and 3. Maksudnya between 2 and 3 sebab numbering starts from here. So sama sahajalah kalau ikutkan. Kan? Betul tak?
Yeah.
Okay,
Yes,
so
miss.
untuk form alkene, you are going to ambil apa? Kita sekarang ni kita nak take out this hydrogen. Untuk you take out this hydrogen, because you want to take out this hydrogen means this gonna be your electrophile. Okay, means siapa nucleophile kita? Nucleophile kita adalah water yang kita remove tadi kat sini. Sini suppose awak ada water kan? Plus water. So this water will act as the nucleophile again. Okay, so water ni dia akan bertindak sebagai nucleophile. So let's say we have this water from here. You have your water with 2 lone pair. Obviously they got abundance of electrons in here. Means dia akan jadi the nucleophile. So this nucleophile will attack the electrophile. The electrophilic site is at this hydrogen. And then this bond, on double bond, kita kena bagi bond ni kepada bond ni, bukan kepada carbon. Okay, kita nak dapatkan double bond, bila nak jadi double bond, bond kepada bond. Kalau yang dalam rearrangement tadi, kita bukan nak di bond sebab tu bond kepada carbon. Boleh? Yang ni pun kena hati-hati. Salah lukis memang salah terus awak, markah hilang. Sangat particular.
Okay, miss.
Alright. Okay, lepas tu kita dah remove ni, kita akan dapatlah kita punya alkene. So, our final product, kita akan dapat apa nanti? Water ke? Silap. Bukan water, bukan water. Ada yang lagi
Acid
kuat
kan,
pada water.
miss?
Yes. Ada yang lagi kuat pada water iaitu O negative SO3H. Okay, yang this one yang tadi. Yang awal tadi tu. Water pun boleh tapi comparing water dengan water dengan this acid, yang ni lagi kuat lah sebab dia negative charge. So sama juga, this lone pair will take up this hydrogen. So lastly, you will get CH3, CH, double bond, C, CH3, CH2, CH3. Okay, last kali dapat tak final product sama macam yang kita suggest? Allah, sama yang kita suggest major product tu? Sama kan?
Sama.
This one.
Sama, miss.
This one. Itulah tu caranya. So kalau muat satu page tu, boleh je terus awak buat dalam satu page. Asalkan nampaklah the movement of electrons. So sekarang ni, question number 3. Okay, question number 3, it asks you to define Markovnikov rules. Okay, Markovnikov rule is basically apa? Dia berlaku pada preparations of alkene. Kalau Markovnikov, dia berlaku pada elimination juga ke? Tadi eliminations, preparations of alkene, sekarang
Addition.
Addition.
the reactions of alkene kan?
Addition.
Yes, reactions on alkene itself, okay? Yes, in other words, dia adalah electrophilic addition. Okay, maksudnya dia hanya antara 6 tu sahaja. Kita boleh apply this Markovnikov. Okay, apa yang Markovnikov cakap? Markovnikov kata, in additions of HX, if you have 2 different things to be added to an alkene, okay, so this suggests, if you want to add these 2 things, tak kisah HX ke HOH ke, whatever, hydrogen mestilah ditambah pada carbon with the most number of hydrogen. Okay, itu syarat dia. Tu kalau dia kata follow Markovnikov. Okay. So kalau dia kata follow Markovnikov, awak kena tengok yang mana banyak carbon, yang banyak hydrogen, hydrogen pergi kat situ. Means the rest, yang satu lagi akan masuk dekat carbon yang kurang hydrogen. Kalau sama banyak, ambil je lah mana-mana pun. Okay. So sekarang ni untuk 3B, okay, 3B dia ada bagi structure kan? Dia ada bagi awak structure. So the structure, can you please name this compound? We have this longest carbon chain of 5. We have 1 double bond in here and 2 substituents. What is the name of this compound? How are we going to name this? Kita start dengan apa dulu?
2, 3.
Start dengan apa dulu? Kalau parent apa? Parent and suffix dia?
Cyclopentene.
Pentene kan?
Yes, Miss.
Cyclopentene awak kat carbon nombor berapa? Boleh tak letak nombor?
Tak boleh.
Tak boleh sebab dia boleh buat positional isomer dan kita ada dua substituent. Numbering nak start pada kiri ke kanan?
Kiri.
The kiri. So we have 1, 2, and 3. So the name gonna be 1 cyclopentene, is it? With hyphens.
Yes.
Yes.
Then at carbon number 3, we have 1 and 3, we have exactly the same substituent. So we have 1, 3 means we're going to use the prefix of di. So
Dimethyl.
apa yang di? Yes, dimethyl. Okay, so we have this dimethyl. Don't leave any space between them. Okay, so this is 1,3-dimethyl 1-cyclopentene. Now undergo reaction to form certain compounds. So kita start dengan A dulu. Let's say we react them with hydrogen gas in platinum. Platinum as the catalyst. Okay, what kind of product to be formed? Bila kita buat reactions on alkene, adakah kita masih akan dapat alkene on our product side?
No.
No.
No. Jadi dalam kes ni, tak ada apa dah lah, dia jadi macam ni je kan?
Yes.
Kalau nak tunjuk boleh, dah masuk hydrogen, hydrogen masuk. Just nak bagi nampak lah perbezaan. Boleh?
Boleh, Miss.
Okay, second reactions, we want to form B by reacting the Br2 in water. Okay, Br2 in water, this is basically halogenations. Okay, bila kita sebut halogenations, we want to add halogen, is it?
Yes, Miss.
Bila masuk halogen, awak aim nak masukkan Br and Br at both carbon. But at the moment, you have water as your solvent. Water is a polar or non-polar molecule. So polar molecule awak, okay, kita ada polar molecule. Bila polar molecule, dia akan involve tak dalam reactions tu? Kita kan aim nak hilangkan double bond, masukkan Br dengan Br. Tapi sekarang kita ada polar solvent. Adakah kita akan masukkan dua-dua Br? Br2 in water, kita nak masukkan siapa?
Masukkan BR dengan OH.
Yes, Br dengan OH. Okay, now when we have two selections, we somehow need to apply this Markovnikov rules lah. Tapi kita tak ada hydrogen. So siapa yang akan dominate? Kalau tak ada hydrogen, kita akan tengok reaction tu nama apa? Siapa yang dominate dia? Halogen lah kan?
Yes.
Yes, halogen.
Okay, so halogen will be added to the carbon with most number of hydrogens. Jadi sekarang awak tengok either carbon number 1 or 2, who's got greater number of hydrogens? On the carbon itself, bukannya neighboring carbon. On the carbon itself, who's got greater number of hydrogens?
Carbon number 2.
Carbon number 2 got 2 hydrogen on them, while carbon number 1 you got only 1 hydrogen on them. Jadi Br akan masuk pada carbon number 2. Dia melanggar. Oh my god. Tak apalah. Okay. OH akan masuk pada carbon number 1 ni. Tapi sebenarnya Wak, bila dia dah tak ada double bond, the numbering akan start daripada kalau OH double. Okay, next one kita ada reactions with siapa pula? To form C, we're gonna react Cl2. Okay, we have now Cl2 in CH2Cl2. So we know this CH2Cl2 is simply inert solvent. So bila dia inert solvent, adakah dia akan take part dalam reactions? Tak, jadi kita aim nak masukkan Cl sahajalah. Bila nak masukkan exactly the same bagaimana tu substituent, jadi tak boleh nak tengok carbon yang buat hydrogen nak masuk je 2 Cl dan Cl, okay? Okay, lagi. Kita ada reactions dengan siapa lagi? Okay, reactions kita lagi dengan siapa Wak?
Dengan HBr.
See now we have only HBr. Okay. So HBr, if the questions didn't say anything, okay, if the questions didn't say anything about the anti-Markovnikov or in supper, kita assume dia dalam unit solvent je lah. So we aim to add only hydrogen and Br. But in some cases, usually takes place for bromine, okay, dia akan cakap anti-Markovnikov kadang-kadang ataupun with the presence of acid peroxide. Yang tu please bear in mind. Kadang-kadang kan, dia bagi awak reactant, dia bagi awak 1,3-dimethyl 1-cyclopentene, tiba-tiba dia buat produk. And awak kena tengok betul-betul, produk awak tu Br masuk dekat mana. Takut dia letak dekat yang Br masuk kepada more hydrogens on the carbon, means dia adalah anti-Markovnikov. So kena hati-hati bila provide the reagent. Okay, for this case only in inert solvent, means kita akan form only H and Br attached to it. So H akan masuk carbon number 2 with greater number of hydrogens, and Br akan masuk at carbon number 1 with less number of hydrogen attached to the carbon. Okay.
Okay.
Last but not least is reactions with H2O acidified water. Kiranya acidified water lah. We have H2O and H+. Jadi sekaligus lah sama. Jadi kalau kita nak masukkan H2O dengan H+, kita akan dapat
Alkohol.
alcohol. So alcohol bila kita ada two selections, H dengan OH, H nak masuk kat carbon nombor 2, OH masuk carbon nombor 1
Dua.
sebab dia follow Markovnikov
Satu.
rules. Yes, masuk nombor 1, OH sebab dia follow Markovnikov. Bila ada pilihan, perlu dia pilih prioritas lah yang mana. Okay, right. Itu sahaja kan untuk our one. Okay, itu sahaja. Right, kalau tak ada apa-apa soalan, saya nak dismiss kelas. Thank you everyone.
Thank you.
Thank you.
Thank you,
Thank
Miss.
you, Miss.